All right, I guess that promise is out in the open now. There's no way for me to back out of it and say, well, I'm not planning to do live coding. Um, so before I really get started, I want to ask you a favor. Because in my experience, when coding, whether live on stage or just behind your desk, things will go wrong. And I see this as a massive a group effort to create good code, right? So if you see me make a mistake, please tell me, right? Because I will make some. And I did it in the past as well because I've seen some really ugly code in the past, and most of that code was my own, right? So the code you generally create tends to become very ugly the day after. I don't know if something happens during code overnight, but if you look at your code the next day, it looks really crappy. And this is the experiment I started 9 years ago. I was realizing that hey, the stuff that I'm building is not. It doesn't feel right. There's some issues with the types of applications that I'm building, where I get a lot of incidental or accidental complexity, whatever you want to call it. So I was exploring different architectural styles, and the dominant architectural style, I think still today, is the layered architecture. You basically form a number of layers in your code. You put some user interface logic in one layer. That layer communicates with a service layer where you have either business logic or application logic. Different people have different names for it. And in that domain layer, something interesting happens. That's where your domain model lives. And that can either be a very rich domain model or a very anemic one, which is essentially just the code representation of some entities that live in a database. And if you have this domain model and you look at your services, in the beginning, when you work on a greenfield project especially, you'll find that these services map really nicely to one of these entities. And the next service you build, it's the same story. It maps really nice. And then there's this third service, or nth service, if you will, and it maps to everything. There's always this one service that needs to access a bit of everything everywhere. And that's where problems start. You get these pretty normal SQL queries. So this is a SQL query that was fortunately not written by me, and even more fortunately not maintained by me. Just imagine the needing to maintain this query. Now, the person that gave me this query made me promise that it would not be readable on slides. And so I put this on, and it's been on my slides for quite a while. I just love this one. I love to show this one around. At some point, I was at a meetup, and they use this high-definition projector, and you could actually clearly see all the characters. And I was like, ooh. Did I break my promise? So I actually spent some time reading the query. And even if you can read all the individual characters in the query, you can still not read the query. So I kept to my promise. I'll give you a little summary. There's 22 joins and 6 subqueries in this one. Any volunteers to maintain it? Okay, I'll have to tell him no again. So what typically happens when we encounter problems, and this is I would say a big thing in our industry. If we have a problem, we look at technology to solve it generally. So what we do is, well, in this example, we add a lot of caches, session replications, more caches. I love worker pools. Doing things asynchronously makes everything faster. So many people believe. Some more caches everywhere. So is this going to help us build better software? Well, definitely not. So instead of building something that we believe is fast, and well, you can like it or dislike it, but it depends on what you compare it with. It might not even be fast, but we know this is a machine designed to go at a certain speed and take corners at a certain speed. But software projects mostly look like this. So it has all the physical characteristics of the car we saw earlier, right? It has the side skirts, that's for aerodynamics. It has a spoiler, so it can go through corners very fast, right? Something tells me that this car is a lot slower than if you would just take everything off. Right. Now back to software, and I like pictures because they show the sort of state of mind that I'm in, the way I think about these the projects that I see. But there's a thing in software engineering called the big ball of mud. Who's not familiar with the big ball of mud? So it's called the big ball of mud because if you have a ball of mud, it has no structure, right? It's a ball, but you can't see the original pieces that made up the mud earlier, right? So everything is gone, and the only thing you can really do is add more mud to it. I found a picture of the big ball of mud, and the problem with it is that it's not really made of mud, right? So I guess this is where the term code smell comes from. And in this particular case, we have the architect sitting on top of his creation, not realizing that what he has created is absolutely senseless. And these little creatures, they defend their big ball of mud to the death, right? Just like software architects, you could say. So this was around 9 years ago. I realized that I'm doing something wrong. I'm doing something terribly wrong, and I'm doing it over and over and over again. And I want to stop doing that. So I started experimenting, and I posted my experiment first on Google Code. That was later GitHub was more popular, and I think Google Code it doesn't exist anymore. But I put it on GitHub, and of course you need a name if you put a project there. The original name was not Axon, but that became the name when some organization in France contacted me and said, "We are using your framework in production." And at that point, it was an experiment. That was a piece of code with a blog about how I thought this might be a good idea. They thought that as well. They started using it, and well, fortunately nowadays it's used by more than just that one company. So Axon is an open source framework, Apache 2 license. You can just grab your copy and play around with it if you want. And the approach I took in these projects was to, or not in the projects, in my pet project, was to apply CQRS, Command Query Responsibility Segregation. Who is not aware of CQRS, or who does not know what CQRS is? 1, 2. That's very little. So I've been giving talks about CQRS for a couple of years. In the beginning, it was like this amount of hands for who knows CQRS. So we're slowly getting there. So the idea of CQRS is essentially what you see on screen. Instead, we have an application, and we divide the responsibility of that application into two parts. One part is responsible for the commands, and one part is responsible for the queries. Commands tell the application that you want to change something. There's something you want to do. So you create a part of an application that can do the validation and then checks what it really needs to do, what are the actions I need to take based on this user demand. Right? And on the other side, there's the projections. And projections are designed to provide information to users or other systems, but provide information about the state of your application. Right? And we separate those because we see them as clearly different responsibilities of an application. Now somehow we need to synchronize the two. If you will do something on one side, you would like to see some changes in the queries that you do on the other side. Events are a very popular way to propagate these changes. Now what we can do when we have these different models is take the different non-functional requirements into account. And as an example, I've set some performance requirements in these red boxes. So the part of the model that requires you to handle 1 million transactions per second with a latency less than 10 milliseconds will have much more design effort going into it than a model that just needs 20 requests per second with a responsibility of 100 milliseconds. So splitting these allows us to focus on the areas where we need to focus most. And there's something special about these events. So we can emit events to to show the changes that have occurred in the past, but there's something special to them in the fact that they retain their value. Something that happened is not only important to remember the moment it happened. Sometimes it's very valuable to go back and find out what happened. If you're in banking, your systems are full of audit trails. Right? So these events, they could be an audit trail. So to be able to do that, in typical systems, what we do is we store the state of things, right? We know the current state, and if we want to know the past, we either open log files or hope that we have backups of that state of other moments, or we go through great lengths of creating models that have this history concept inside of them. That is a lot of accidental complexity in either case. So instead of just saying I've got a shipment with ID 123 that has one luxury chair in it for almost 400 euros that has been returned, you could say, well, let's event source this. Let's store everything that happened to this order instead of just storing the current state. So what we store is at some point we have created this order and it was assigned a certain identifier. We added 2 items to that order. Then we removed 1 item. Then the order was confirmed. Then it was shipped. Then it was cancelled by the user. Now that gives us a lot more information about what has been going on than just the state. The state tells us is what somebody ordered a chair and sent it back. Right. Now we know he had the intent to order 2 chairs, removed 1 before confirming and then confirmed. That might be very typical behavior of somebody who doesn't know whether he really likes that chair, so I'll just order 1 and then send it back if I don't like it. So there might be benefit if you gather this information of all of the orders that go through a system. You might get information from that and maybe prevent shipping them, or I don't know, get prepared for the return shipment. So the value of event sourcing is in having this audit trail. It's in having the possibility to do analytics. I've spoken to airline companies using event sourcing because they want to know whether they should cancel if there's a technical problem on an aircraft on the ground. They want to know, should we cancel the flight? Should we delay it and try to get maintenance to fix the problem? Their system, the systems of flights, is so complex that it's very hard to predict exactly what's going to happen. So they want to measure, they want to gather all this historical information so that they can do machine learning. Probably they'll mention blockchain a few times just to make sure it's hipster. And they'll do that analysis to find out what they can do best in that situation. But to be able to do that analysis, we need the fine-grained things, the facts that happened in the past. I like event storming mostly because it allows me to improve the modeling practice. It allows you to create models that capture the essence of the problem much better than if you do a typical project or a typical approach where you store state and have a lot of restrictions by ORMs and things like that. Given when then testing is very nice. Given these events in the past, when I do this command, I expect some more events. I expect things to have happened, right? You can express your tests in pure functional interaction with your system, right, on a very low level. But the biggest advantage, I would say, of event sourcing is that you have this power of not now. The ability to just say, that is a great feature. And yes, I understand you want this historical view of the world. Let's not build it now. It's a good idea for tomorrow. Or whenever. And you can always go back in time because you've gathered all the events, you've got all the information, you've got all the things that happened. So you can just create a new component and replay all of history onto it. Now you might think, how's that going to work? And this is where the scary part starts. So who of you is a Java developer? Who of you is not feeling like raising his hand? But you're a Java developer, not wanting to raise your hand, or whatever. So Axon is a framework for the JVM. So Obviously, everything is in Java, but like most languages, most of it is in English, so I don't think that will be a problem. So what you can see here, I've got a little project set up, and it uses Java and Kotlin. And the thing I like about Kotlin very, very much is the fact that you can define these data classes just in a single line. They're very nice, concise classes. For the rest, I'm pretty old school. I just still use Java. So I've got a bunch of messages here, and some of them are commands and some of them are events. I've got so this is a demo application where it's a bike rental application. So I'm Dutch, so we do everything by bike, and every now and then you want to rent a bike somewhere. So this application allows you to register a bike and then rent it out to somebody who then delivers it, gives it back at some location, and then somebody else can rent it and move it to another location. So we have some commands to register the bike, rent the bike, and return the bike. And since it's a very simple application, the events are very similar. You have a bike registered, a bike rented, and a bike returned. In the project structure on the left, you can see the command package and a query package. I separated that out. I created some classes just to make sure that everything compiles at least when I start the talk. But there's nothing much to this. So this is the command package, and the most important part of a command model is to define your aggregates. And an aggregate is a domain-driven design concept. It's a group of entities that together form a consistent unit when it comes to data changes. So every change within this bike entity is going to be consistent. Right. Now everything needs an identifier. And because I'm really lazy right now, I'm going to make everything a string. And essentially we're going to define the behavior of this bike. So we're going to define some command handlers, right? These are the commands that we can send to this bike. What is this bike going to do? Well, there's a command to register a new bike. That starts the life cycle of a new bike. So we'll create a constructor for that. And we call it register bike command. And we're going to approach this in an event sourcing way. So the only thing we will store is the history of this bike. Right. So instead of storing any state, we don't care about state anymore in this class. We care about the identifier. The identifier is part of the state, but we only care about the elements of the bike state that we need to change the behavior for incoming commands. And we'll get to that in a second because there's nothing much for this one. So what we can do is apply a new bike registered event. And we get the bike ID, and a bike is registered and it starts at a certain location, right? We need a starting point for our interesting bike rental journey, and we get that from the command. This is the only thing we really want to do on this. Now there's one mandatory field that we always need to set, and that's the identifier. So I'm going to quickly type this out. Void on. This.id equals e.getID. So now we're going to say, well, when a bike was registered, when this bike was registered to the state of this bike, it means that the identifier has to be set. Axon needs that identifier because all the events that are emitted, they need to show the origin. From where were they emitted? Right. So that's what the identifier is for. Now the interesting part comes when we're trying to rent out a bike. So I'm going to define a method. The name doesn't really matter. Axon doesn't care about names of methods. And we say rent bike command. So when we rent a bike, now suddenly we have some different behavior depending on whether the bike was already rented out. Right? You cannot rent out a bike to someone if somebody's already renting it. Right? That doesn't work. So we need to validate that somehow. So we have an if. If what? We don't have any state. So what is it that we care about? Well, if it is not rented out, then we apply new bike rented event. Whoops. Right. So we're saying if the bike wasn't rented out, then we're going to rent it out. Otherwise, well, then what? Throw new illegal. Don't do this at home. Right. Of course, we can invert the if and get the exceptions on top, but that's code style. And I can genuinely say, don't care about that. Not right now. Of course, we need a field. Now there's a bit of a problem. We have a warning in our IDE that says, well, you have a field, you're reading from it, but you're never writing to it. So now we have to think about what are the events that are going to change this state. Well, there's two events that can happen that will change whether it was rented out. I think I have a quick one. So if the bike rented event happens, then we say this dot rented out equals true. If we have the bike returned event, then we say rented out is false. Of course, we don't have an operation to return the bike yet, so that's the last one we're going to do. Bike returned event, return bike command. And we say if the bike was rented out, because we can only return a bike if it was not already returned, right? Otherwise, we'll see otherwise what we're going to do. And in this case, we apply a new bike returned. Now this might feel a bit like a Back to the Future kind of, you're applying an event, but then doing the state change after as a result of that. And that's one of the parts that you have to get used to, I guess. But it feels much more natural to say, well, if the bike is rented out, then it was returned. That's it. That's what happened. And the state changes are not so much for the current command or the command that we're handling right now. That's going to be for the next one coming in, so that we validate that properly. And we take the command dot get location. And otherwise, what do we do? Well, let's throw an exception. Normally you would say ignore it or check if the location is the current, or there's all sorts of behavior you can think of. But we're going to do the nice and ugly illegal state exception. Right. So this should actually run. It's not going to do much interesting stuff. But I should be able to run this and then register a bike, and let's try to rent it out twice. So I've got my, I already prepared a controller because I didn't really want to type that out on stage. That's going to be a really boring session, even for me. So what I've created is a couple of get mappings to get some information. We'll have to create those that part. But there's a put to register a bike, etc. So if my application started, can you read the code in the back, by the way? Yeah. Maybe I should have started asking that. But anyway, so let's. Oh, cool! We're issuing a bike in Vilnius. Well, let's see what happens. It hasn't started yet. Slow machine syndrome. There we go. So I can issue that bike and I get a 200 back. So the bike issued worked, right? It's returning the identifier 1234. I'm also providing it in the request because it makes it easier to prepare. So we have the, we can rent it out. Let me rent that bike. The bike was already rented out. Great. So I made a mistake and nobody told me. Did you do that on purpose? Oh, thanks. Very kind. So it was rented out. Well, no. It's rented out false. I'm sorry? Great. Noob mistake, right? There you go. That one's easy to spot. Come on. All right, let's go to the HTTP requests. We rent the bike. Yes, I've got my bike. Cool. And I'm trying to rent it again. Oh, it's already rented out. And my colleague, of course not. Right, and then we can return it probably. Oh, we return it in Barcelona. That's an interesting bike ride. And then Steven can pick it up from Barcelona and bring it to wherever, probably back home. Anyway, so this is how the interaction works. But we can't get any state back. And right now I'm going to cheat a bit. And I'm going to... And I know you can't do this in real life. I'm going to do a hard reset on that one, just to save time. Because I don't want to create the full projection right here on stage. But to get information out of our system, what we need to do is create a projection that listens to what happens and what is the kind of information we want to serve to the outside world. In this case, what this application wants to do is show a list of bikes and their current location. So does somebody currently use it, or is it sitting at some place in Barcelona, or does Steven have it right now? So that's the kind of information. So we have an event handler, so that if it was registered, then we mark the location of that registration as its current location. If it was rented out, we set the renter to who currently owns it or is using it, and then if it's returned, we'll set that location, etc. So that allows us to, if we restart the application, to also send GET requests and get information out of that. So the thing that we've been building here is a monolith, right? Everything is in one code base. Now the talk was about Pragmatic Microservices. And I'm doing this on purpose, but the first, what was it, 25 minutes, almost half an hour was spent on building a monolith. And that's the pragmatic approach to building microservices is to build a monolith first. And we should not confuse a monolith with a big ball of mud. Right? For one, the thing on the left does not smell, and it is solid. We can do something with it. It's hard to move. Okay, that's an issue. But microservices are really hard, and there's a couple of statements by Martin Fowler and many others as well. And it's about, are you tall enough? Are you game, right? Are you up for this big challenge? And it's not only the technology, right? It's not just, okay, can you set up a Kubernetes cluster right now? Come on, go, go, go. No, that's not the big issue. The big issue is, what is the boundary of your service? What do you put in one service or in another? So I've had the pleasure to do a lot of reviews on projects, especially those that are in troubled waters. And I noticed that there's a lot of noun-driven design. So a friend of mine started calling this noun-driven design. You see a noun in the description, like customer or order or product or shipment, and then that's a service. So you get order service, shipping product, customer service, shipping service, product service, etc., etc. So you get these entity services. And essentially what's happening is we're using the structure or the approach that we used to build that instead of our nice structured monolith, and then we start to increase the number of deployment units. right? So instead of a single big ball of mud, we get a big mess, right? Imagine the smell of that compared to this. So instead of that, what we need to do is focus on increasing the modularity first. We have to learn to build a nice modular system where that has a very clear structure and organization to its classes and how they communicate. And then we can increase the number of deployment units. But we have to be careful that there are evil anti-modularity forces on every project. Usually they come in the form of project managers telling you to deliver tomorrow. Right? This is what I want and this is when I want it. So we cut corners. We increase our technical debt. Well, technical debt is one of these arrows, right? It's one of these things that gets you back into the distributed big ball of mud, I guess. So the approach we suggest is not to go from some idea that you have and try to go straight into microservices, because that landscape is not very friendly. Right? And you'll get lost and end up in the wrong place. Instead, we suggest build a monolith first and then extract these components. And as you go on, you can extract more if the non-functionals tell you that you should extract more. And maybe someday you can even go serverless. Wow, that would be awesome. To be able to do that, we need something that we call location transparency. It's the concept that two components are not aware of their respective location. As soon as that happens, they don't care anymore whether they're communicating, whether they're sending their events or commands or queries to another component that sits in the same monolith or on a different monolith on the same machine, or maybe even a serverless component. We don't care anymore, right? And that same concept allows us to scale out, but it allows us also to, within that monolith, to safeguard the structure inside of it, right? So there's 3 types of messages that we want to be able to send between these components. They're command, events, and queries. So events are usually published. They describe something that happened in the past. They're a fact. There's no way in denying them. If you don't like what happens, if you have a component receiving an event and it doesn't like it, too bad. It happened. Deal with it. Do whatever you need to do. You cannot ignore it. Commands, on the other hand, they're an intent for somebody to change the state of a system. So they go somewhere, they're routed to some component that is responsible for executing the change associated with that intent. You can reject that. You can deny it. You can do whatever you like. Right? And then there's queries, and that's the request for information. There's different styles of queries that you could do. There's a very typical one is the point-to-point. I can just point at somebody and ask a question, right? Are you a Java developer? I've got my answer, right? That's just one way of doing this. The other way is I can ask a question to everybody, and that's what I've done a couple of times already. I get multiple answers, and I do whatever I do with those answers. I combine them. I have my little map reduce function, and then I continue my story. But you can also do subscription queries where you can say, well, keep me up to date on something, right? So what's the latest news? And then you keep on feeding me with news as it happens, right? Let's not try that in practice. So what we can do relatively simply in my application here is I can stop this. How much time do I have left? 5 minutes. Should be plenty for microservices, isn't it? So what we need to do is tell our different components that we want to run them only in a profile. So I'm not going to actually distribute this, start multiple projects. So I'm going to use Spring to cheat and set profiles here. So this is my command profile. Just make sure my naming is correct. Lowercase, there you go. And we set this profile on query, copy. Yes, I know. There we go. So these classes will only be used when actually I start the application with that specific profile on it. And I think I have a UI as well. No, that's the one. Just to make sure I'm doing it correctly. So I start 3 instances of my application right now: command, query, and the plain UI. Now the command profile will only have the command model in it. The query profile, which is going to be a different process, will have the query in it, and the other one will only have the UI in it. And that starts on port 8080, so I actually know what to access. And we should now be able... This is usually where the drum rolls would start, because this is where everything can go wrong. So I can issue a bike. We have to change the ID. Let's start it in Barcelona right away. Oh, I can run this. And it still works. Right. So I can rent out my bike. 4, 3, 2, 1. Do we have any feedback on which application is doing what? Actually, we don't here. Fortunately, I have a little dashboard I can see. So I can see here that I've got a number of commands. I've issued 1 rent bike command and 1 registered bike that has been going to the bike rental command application. Right? That's this one. Now I didn't change any logic. I didn't tell anything to send commands of a specific type anywhere. Right? This is where the location transparency comes in. It's just an application saying, well, this is the kind of handlers I've got. So if you want to send some messages, route them to me. The UI you saw here, that was the Axon server, is also something. It's open source. You can just download it. You can Docker. There's a Docker image for it. You can just run it. The applications can connect to that, and then the routing becomes transparent. So that gives you full control of how you want to distribute your components. Do you want to have them in a single monolith? Do you want to spread them out in different components? And I've just proven that in 3 minutes you can turn a monolith into microservices. Unfortunately, I've only proven that you can do that with pretty useless code, but still, it's a start. So that puts us back into, gives us back the opportunity of applying rule number 1 of distributed computing. Who knows the rule number 1 of distributed computing? Don't. Right. So at least we can stick to that rule and obey to that rule for a little while until we really get the non-functionals in place that tell us to use them. So you can try all this for yourself. I will push the Dev Days branch to GitHub right after the talk. So if you want to check it out, you can check the source code out right there. The sources for Axon, if you want to spend a couple of days reading that, that's good fun too. I'm looking forward to any pull requests that you have. And if you want to download the full thing, there's a download page on our website that includes a quick start guide and allows you to get started more in depth for yourself.